Hello students, welcome to VHSE classes and I'm Dr. Bharat Pareek and today we are going to discuss another important topic, that is type of sampling methods. In a previous lectures we have discussed some of the basic concepts related to sample and sampling. Now let's talk about the very important, and I say it has its own practical implication, that is a types of sampling method. So already let's talk about what is the meaning of this. A sampling method refers to any technique or procedure the researcher would like to adapt in selecting the item for the sample. So what it is? It is a technique. Basically, it is a technique or procedures that you adapt to draw the sample from the population. That we call it methods of sampling. So we assume we assume in this lecture we are going to discuss many different types of methods that usually researcher can adopt while selecting the sample from the population. Primarily, if we talk about, there are two basic types of sampling methods. We have one is probability sampling methods. It is also known as a random sampling method, and we have non-probability sampling methods. That means the methods where we select the subject based on non-random criteria. Okay, so if I just talk briefly about these, under probability methods we have different types, as you can see here, like simple random sampling, stratified random sampling, we have systematic random sampling, cluster and area sampling. We'll discuss all that in detail. Whereas in non-probability methods, we have a purposive, convenient, quota sampling, snowball sampling, sequential sampling. So we are also going to discuss some of these topics in detail. So let's discuss these methods in detail one by one. Now, let's talk and understand the basic meaning of probability and non-probability methods of sampling. Now, what is probability? It involves the random selection of the sample from the population. Yes, what it is? Random selection. Please remember this. Random selection. That is a very important term that you need to remember. Random means where everyone in a population have an equal chance of being selected in the research, okay, or in the study. As you can see, everyone in the population should have an equal chance of getting selected. For example, if researcher has population of 100 people, every person would have chance 1 in 100. So how you ensure that everyone get a equal chance? So maybe by adopting a lottery method, you can write, the name of all these 100 people in a chit, and from there you select. So if suppose there are 100 people, there will be 100 name in the list, and then we select randomly. Then we select some of the subject randomly. So there we say everyone has an equal chance. In contrast to that, the another important technique here is a non-probability sampling. What it is? So here the word is non-random. Non-random. That is a term. Researchers select the sample based on the subjective judgment of the researcher rather than the random selection. So other than the random method means like lottery method, or you adopt some other methods where everyone is being given an equal chance. Here you select the subject for your population maybe based on your wisdom or subjective judgment, or purposefully by making certain understanding about the population characteristics. So that kind of method is known as a non-probability sampling method. Now, both the methods are effectively used in nursing, and of course the probability is more desirable, because whenever you ensure that every element in a population has an equal chance, then it is considered more superior, prestigious than the non-probability. But at the same time, we should also understand this, it is practically sometimes not possible, not feasible to go for probability sampling. In that case, we can go for the non-probability sampling methods. Now, let's talk about probability sampling method. So abhi aapko this thing is clear. What is probability sampling? A sampling where we select the data based on random. Non-probability means select the data on the non-random basis. Now let's talk about the probability sampling methods in detail. Now what is that? Sample elements has some known probability of being selected. What do you mean by that? Known probability. Let's say there are 10 subjects, okay, and I just want to select the 5 from that. So every person in a 10, like for example, subject 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Everybody will be given a equal chance. Now they are written there. Okay, so what I do, I'll just write the name, I'll prepare the list of all these 10 people. Now suppose I'll take randomly. So who will come? I'll write the name in chits and I'll just take a 5 chits. Randomly I can just take a 5 chits. So the 5 people will be selected. So the goal of probability sampling is to examine the representative elements of the population. So ultimately, because probability is superior, as I told you. Why? Because here every subject, every element of a population has an equal chance of selection. Now, if you talk about the various methods under probability techniques of sampling, we have a simple random sampling, stratified, area sampling, systematic sampling, and cluster sampling. So we'll discuss all that one by one detail. कौन-कौन से बताया मैंने? Simple random sampling, stratified random sampling, area sampling, systematic sampling, and cluster sampling. Please do remember that. Now, first we'll talk about the simple random sampling. What is that simple random? Name is simple. Each subset of individual has the same probability of being chosen for the sample as any other subject in the individual. The example which I have given you, as you can see here, suppose this is a population of 12 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. There are 12 people. Now you want to take a select, you want to select the 3 people from that. So randomly will go as you have taken, let's say number 3 has selected, number 5 was selected, and number 11 was selected. There is nothing else. It's very simple. Okay. So here in this simple random sampling, what you assume? You assume that your population is homogeneous. And usually this kind of a random sampling method is always suggested if your population is homogeneous in nature. Homogeneous means they more or less they have a similar characteristics. For example, if I want to collect the select the sample from BSc first years on different colleges in a particular state. So I know that BSc first year students would have a similar characteristics in terms of their age, maybe gender, maybe their educational background, okay, socioeconomic conditions, all that. So I can go for the simple random sampling for that. So it is simple, it's very simple method. Now, what are the steps in this? Identify the accessible population, that is the one. Accessible population means, if you remember my earlier lecture where I told you, accessible population is also known as a source population. What is we call that? Source population, right? So identify the accessible population, then develop the sampling frame, then listing. Like as you can see, there are 12 people in this. If you see, as you can see, so I just made a list of all these people. Okay, like 1, 2, 3, 4, like that. I have to make the list. Okay, and method, then select from the list how you are going to draw. So we have a lottery methods where you can, you can put the name of all these people in a chit. You can just mix up it well, and then you can draw the chits. Okay, and then there's a new technique that what we were random tables. Okay, that's also a method we can use. So so many random tables are available, 2 digits table, 3 digits tables, and online methods are also there. So once you make a sampling element or a list, what you can do, you can give few commands to your system and system will generate. Like for example, if suppose these 12 people are there and I just put my starting number is 1 and my end point is 12. So once I put that, so that list will identify, let's suppose I just want to get the 3 people from this. So that automatically the software will give me the 3 numbers, and the person or a subject who's assigned that particular number will become my sample. So that can be done. Now, if you talk about merits and demerits of simple random sampling, so quickly if we talk about, it requires a knowledge of population to develop the sampling frame. Yeah, that's a very, very important point. Okay, sampling frame means listing all the people. And I would like to tell you here that there is a considerable confusion about random sampling or choosing somebody those who are available accidentally. Because usually we talk, okay, I just took some few people, random people. No, to have a random sampling, you need to first prepare the sampling frame. Okay, that's very, very important. Frame means listing all the peoples. Then, so if you don't have a knowledge of these people, then you cannot make a frame. Like for example, you want to collect the random data from people, those who are visiting to railway station. So how will you prepare the frame? It's not possible. Or visiting to airport. Okay. So this method free from classification error, because here you assume that all the populations are homogeneous, they exhibit similar characteristics, so there will not be any classification error. Like for example, classification in some of the sampling methods like stratified random sampling, where we select the sample based on a specific characteristic. Like for example, I just want to make sure male versus female, educated versus uneducated, rural versus urban. If I assume that my population have all these characteristics and I want to ensure that everyone should have participation in the research, then I go for some kind of other grouping one. So that grouping is not there, because I know we don't do grouping in the simple random sampling. Sampling error can be easily computed and the accuracy of estimation easily. So the sampling error, because whenever you collect the data based on a sample, it always will have certain errors. In my previous lecture, I have already told you that sampling method will have sampling error. You cannot eliminate the error or bring it at zero. What you can do is you can control it to the maximum extent, or you can measure it. Okay, so that can be done. Then it requires for parametric test. Yes, if you, there's another important merit of simple random sampling or all random sampling method is that whenever you do a statistical calculations, especially the parametric test, where you want to test the hypothesis based on the test like t-test, z-test, okay, or which assume to have a normality of distribution, then this method is very, very effective. Then if you quickly look at the demerits, does not make the use of knowledge about the population as in the judgmental sampling. Yeah, that's what this is. Because in random sample, researcher do not have any control that who should be the part, who should be the part of a research. So sometimes you feel that that particular subject can be a good informant or can be a good sample for that research. But as it is not in your hand, therefore you cannot select that person. So in judgmental sampling, where you select the people because you feel that this person would be a better sample for the research, that scope is not there in a simple random sampling. Time and cost of collection of data is too large. Okay, that's because you have to make a sampling frame, and then you should go for a selection of methods, random table or software based, whatever. So sometimes it takes time. It is often difficult for investigator to have up to date list of all elements. I think the biggest drawback or demerit, if I talk about any random sampling, is that having a updated sampling frame. If your sample frame is not updated, so it is something that have an error, and this is something called what? Please just give me, if there is a just give me the answer for this. If there is a defect in a sampling frame, what kind of error we call it? Okay, so then not possible for rarely occurred phenomena. Yeah, sometimes you have very less sample, so you cannot random. Like for example, there are only 5 people you identify having a specific disease. Now from there you cannot take only 2 because you want to do a random sampling. You have to take a complete enumeration in that way. Okay, so it is not for the rare phenomena. So that is about the simple random sampling. Now we'll talk about another important technique here is a stratified random sampling. What is a stratified random sampling? Because the entire population is divided into the multiple non-overlapping homogeneous group or strata. If you see the population characteristics, like if I continue the same example, a nursing students, okay, nursing student. So nursing student include first year also, second year, third year and fourth year. If I talk about BSc Nursing students, and you just want to select the 100 sample from all BSc Nursing students. So you have 2 choices. Your first choice is that irrespective of making the specific groups, you just take random. So in that there are possibility like you may get, for first year you get let's say 40 people, from second year you got only 20, from here you got less number, maybe 15. Okay, like that you can get here, from here you got only 5 people. So that is a problem. And sometime under representation or over representation become a problem. So what you can do here is, in this particular case, what you can do, instead of having a simple random sampling, you can have strata. Okay, like first year, suppose there are 60 students, second year there are let's say 58 students, third year there are 55 students, and fourth year there are 45 students. Okay? These are the students. So what you can do is, you will ensure that every student or every strata means grouping, like first year, second year, third year, fourth year, will represent the sampling. So I suppose I have taken from 60, I have taken 20, here I have taken 20, then 20 and 20. So now total my sample is become 80, or if I say 25 from each, so my sample become 100. So these 80 will represent or will ensure adequate representation of first year, second year, third year and fourth year. So that kind of sampling is known as a stratified random sampling. So what we do here, subject characteristics such as age, gender, educational background are the example of variables. So what we do, instead of making a simple element or a sampling frame, we have to make a frame of different groups where we classify and keep the people in a different group based on certain specific characteristics. Okay, now the question comes, what is the need of doing this? Why we need to make a strata? So the answer is very clear. Sometimes, we assume that the outcome may be affected, our outcome will be affected because of these specific characteristics. Like for example, if you want to see the attitude of nursing student towards nursing, so researcher may assume that the first year would have a different attitude as compared to the fourth year. So I don't want to go for a combined or a mixed attitude among students. I just want to see how the first years are different from second year and then third year and then fourth year. So when I have that kind of aim to understand the effect of a specific characteristics, I can have for the stratified random sampling. As you can see here in this, first we have mixed population, from there we made a strata, as you can see green, then blue, then red, and then again blue, sky blue, and then from each strata we selected randomly. You can see there are 4, 4, 4 and 4. So just adequate representation is being ensured in this. Now, next to that, if you talk about, there are various type of stratified random sampling. So I'm just talking about two important type here. This proportionate stratified random sampling and disproportionate stratified random sampling. Please remember, types of stratified sampling, two types. What is that? Proportionate and disproportionate. So name itself indicate proportionate means in a specific proportion to the population. Okay. Disproportionate, I just select a fixed number. Okay, I'll give an example. So in a first proportionate, the stratum sample size is directly proportional to the population size of the entire population strata proportion. Let's say there are 60 in first year and there are 50 in second year. So what is the proportionate? Suppose I'll just take 20% from here and 20% from here. So it is going in that. If population is less, suppose third years are having only 40, so again 20% from that. Okay, so the final number would be different. Okay, the final number would be different here. So that is what we call a proportionate sampling. We select the sample size. Sorry, we select the sample and size is determined based on the population proportion. What is disproportionate? Each stratum will have an equal sample size from each stratum regardless of the size of the strata. Now here is 60, 15, 40. So in disproportionate, what I do? I'll just select, okay, I'll take 20, I'll take 25, 25 and 25 from each. I'm not considering whether they are 40 or not. They are 40, they are 60, they are 50, but still I'll take 25, 25, 25. So sample size would be equal. So that kind of stratified sampling is known as a disproportionate sample size. Okay, so that's the two types of that. Now if I talk about the merits and demerits of stratified random sampling, so the merit is that it's a random sampling, same like simple random sampling. It's it provides more accurate data. You can measure the random sampling error. Okay, it is suitable for the parametric test. Okay, it has an assumption, and random sampling provide an equal chance to everyone. What is a demerit for that? It's a classification one, because now you have made a different classification. So number one, you need a large sample size. Okay, now suppose you have taken 20% or 25 from each, so that's also sample is going 100. Okay, so that much numbers are required. Now suppose there are only 10 first year MSc and 10 second years, then in that way you have to get, let's say, 5 and 5. So this number is not, the 5 number is not sufficient to represent the MSc first year or BSc first year. Same way the 5 is not adequate number to represent the another group. So the first point is you need to take a large sample, or there must be availability of large sample, then only you can go for stratified. Secondly, there would be a classification error, because as you have the different strata, and this strata will cause a classification error. So these are the problem with that. Next, another important random sampling method is a cluster random sampling. So what is that? In a large scale studies where the population is geographically spread out, sampling procedure can be very difficult and time consuming, that we know that. Like for example, if there is a very good example here, a researcher want to interview 100 nurse administrator in India. 100 nurse administrator from different hospitals. 100 names were selected by simple random sampling. Now there are possibility that one nursing administrator you got from Srinagar and another will come from Chennai, another from Kolkata. So visiting to 100 nurse administrator will become practically impossible. Meaning you have to go to the 100 places. So instead of doing that, so because what is practically not possible, so what we can do, we can just make a cluster. Okay, what we can do, we can just make a cluster. Like for example, as you can see, north, okay, east, west, south and central. As you can see, there are 5 clusters we made. So entire India is being divided into 5 clusters: north, east, west, south and central region. Now all the nurse administrator from north will be in one cluster. All the nurse administrator from the eastern side will be in a one cluster, and so on. So as you can see, there are different clusters. Now it is my choice. Instead of going to the everyone, either what I can do, I can just select from every cluster. Let's say I've taken this one person, then from one person from here, then one person from here, or from these clusters I can again select one cluster. Let's say I just randomly select only 2 clusters. So one I got north, this cluster is being selected, and then one south. So now I'll just go to that particular area, and all the nurse administrator into that particular cluster will become my sample. So that kind of sampling is known as a cluster sampling. Okay, let's understand this. So in cluster random sampling, large group of clusters become the sample unit. So as I told you, now this become a unit. So maybe all the nurse administrator in a north region, let's say there are 100 nurse administrator, they will represent a cluster 1. So I will not select one particular person, I'll select the cluster. Okay. To obtain the sample of nurse administrator, the first cluster be sampled could be obtained by doing the simple random sampling and stratified random sampling of the state. So that is easily we can do. Now rest of the thing will remain same as like simple random sampling. One cluster, let's say you got this cluster 1 north, and in north suppose there are 100, okay, 100 nurse administrator in a list. Now how you select 100? You can select by simple random sampling, you can say cluster random sampling, anything that you can adapt, which already I have told you. As you can see here, and the cluster can be a different type. You can make cluster of, like as I said, region wise cluster, a cluster of cities, cluster of hospitals. Okay, that can be done. As you can see, this is your population. Let's say this entire all nurses educator in India. Now you made a different cluster. Okay, all the nurse administrator are in this cluster. Like for example, I say north, east, west, northwest, north, south, in that way, and randomly I have selected these many clusters. As you can see, this is 1, the 2, 3 and 4. So now 4 cluster I have taken. So I don't need to visit each and every corner of a country. I have taken these 4 cluster, and all the nurse administrator in these cluster will become my sample. Okay. And how to select from the cluster? By adapting simple random sampling or cluster sampling, that can be done. So there are, on the basis of different types of clusters you can have, like single stage cluster sampling, 2-stage cluster sampling, or multi-stage cluster sampling. This is also known as a multi-stage sampling. Okay, let's talk about that. What is a single stage cluster sampling? Like as the name suggests, sampling will be done just once only one time. Okay, for example, a researcher want to create a sample of a girl studying in a various colleges across 5 neighboring towns. Using a single stage cluster sampling, the researcher can randomly select the two cluster from the sample. Or if I go with my own example, like as you can see here in simple, what I do, I have taken just 4 cluster, 1, 2, 3 and 4. This is the example of a simple 1-stage cluster. Okay. Now, what is the 2-stage clusters? Instead of selecting all the elements of a cluster, only a handful of members are selected from each cluster by implementing a systematic or random. 2-stage means, let's see the example. Now, suppose I have taken this 4 cluster, and each cluster is having, let's say, for example, this cluster is having 100 people, 100 nurse administrator. Now, 100 administrator again can be clustered as a private hospitals or government hospitals. So again, there's 2 cluster. So suppose I have taken a 1 cluster. In a first stage, what I have taken, I have selected a cluster from the specific population. In the second stage, I again made a cluster of nurse administrator from the private hospitals or nurse administrator from the government hospital. So it's a 2-stage. Similarly, I can go with 3-stage also. Now, then again, for example, from private hospitals, I can make another cluster. For example, the private hospitals, I have a clusters. Like for big hospitals, hospitals having more than 300 bedded hospitals, administrator, and administrator having a less than 300 bedded hospitals. So again, let's say in that particular cluster, there are many hospitals, administrator are into that category. So you can keep on making the clusters based on the strata or based on the things you wanted to do. So that is what we call a single stage, 2-stage or multiple stage clustering sampling. Okay, as you can see here, multi-stage, already I have explained you. Like example is being given here, like divide all the state into 5 clusters, all the state of India, north, east, west, south and central. Then divide each cluster into 6 clusters based on certain things. Okay, maybe further classification is there where you can cluster. Then divide all the colleges from these 6 clusters into the 10 clusters, maybe based on the private, government or whatever. You can have different clusters and you can collect the data from the selected one. So just keep on making the grouping. So that's about this. Now, similar to cluster sampling is known as a area sampling, though both are same only. The difference is if the cluster happen to be some geographical subdivision. Okay, you are making cluster only. And if your cluster is based on some geographical area, like as I said, north, east, west, south, then it is a area sampling. Okay. In other words, so in this cluster sampling is better known as a cluster sampling is better known as a area sampling. In other words, cluster designs where the primary sampling unit represent a cluster of unit based on geographical area. Again and again I'm using the word based on geographical area, then we call it a area sampling. The example is given here is a 1-stage, 2-stage, 3-stage and 4-stage. That you can same example which I have given you. So area sampling is nothing, it is a cluster sampling. But the difference is when your cluster is based on some geographical conditions. Okay. Next type of random sampling is a systematic random sampling. What is a systematic random sampling? Systematic random sampling involves selecting every nth element. Please remember this word, every nth element from the population, such as every 5th, 8th, 20 or 21st element. As you can see here, like suppose there are 11 population, there are 11 people and you have selected that first person always will be selected on random basis. Okay, suppose 11. So first point you have to select based on the random. And then you decide that every third person would be selected. Every third person will be selected. So if first subject was 2, then second subject would be fifth one, and then there will be the 8th subject. The somebody is in a position of 8th or the 11th one. Okay, and there is a one very interesting formula that is being used. With that, we just identify the interval. Like for example, why only fifth person, third person, or sixth person, or 8th person? So there is a simple one of first step is to obtain a list of total population, that is n. Okay, let's say there is a n is a 50, and then sample size. How many samples suppose you want? Suppose you want a sample size of 10. Okay, there is a 50, population is 50, and your sample is 10. You want a sample of 10. So how you can calculate the k? So the k equal to n divided n. So n is a total population is a 50 divided by 10. So that comes to your 10. So every 10th subject, every 10th sample in this sampling element or sampling frame will become your sample. So every 10th element of the population list would be selected. Okay, like for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm writing all this name in that way. Suppose all the names are there. Now close your eyes and select the one, or just make a cheat of selecting the one. Suppose the first sample was for me was 6. So what is my next sample? Say second sample, 6 plus 10. So 16 would be my second sample. Who would be my third sample? Somebody in a position 26. Somebody the next would be somebody is position 37, 36. So this is how we can calculate the systematic random sampling. Okay, but only the problem with the systematic random sampling is that it is not applicable if your population having a specific positioning of the subject. Like for example, suppose in a hospital, the list of all the nurses where every fifth person is the CNO or DNS. So every fifth person, now 10th person is again CNO, then 15th person again CNO. No. So in that case, what if will happen? Even they will have 100% probability of being selected, or they will have a 0 probability of selected. Like for example, and there is 100 people, and I just want to draw the 10 from that. So every 10th person would be there. Okay, every 10th person. So in every 10th means CNO, every 10 CNO. So suppose I have taken a 5 population of 10 subject, sample of 10 subject. So all the people, all the CNOs, because they are always there on the 10th number. Every 10% is CNO. So they will have a more chances as compared to others of being selected. So if your sampling frame having a specific pattern, as I've given example here, you cannot use a systematic random sampling. Secondly, if the first subject is not being selected randomly, then it is not a systematic random sampling. It is systematic, then not a random one. So please take care of these two things. So with that, we complete the different types of probability sampling methods. So overall, if I conclude that probability sampling methods are very prestigious and effective methods of selecting the sample representative from the population. It is primarily a method which is designed to provide equal chance to every element of being selected. So we can use different methods like a lottery methods or random sample number or random chance are being provided. So different methods we have discussed, like simple random sampling, where we select the data by considering the population as a single proportion. Then we have a stratified random sampling, where we divide the population based on some specific characteristics or state or group. Then we have discussed about the cluster sampling, where the sampling unit will become your cluster. The cluster, if happen to be based on some geographical area, we call it a area sampling. And lastly, we have discussed about systematic random sampling, where we apply certain formula and a specific subject in that sampling frame or positioned in a sampling frame would be selected, as I give an example by applying the formula. So with that, we complete various techniques of probability sampling methods. Of course, these are very, very effective, and I always suggest and prefer you should go for non-probability sampling only and only when probability sampling method is not possible. Thank you so much.